This one is from the JEE Advanced 2020. Let's solve it. The problem requires us to evaluate this integral. The obvious thing to do is to multiply out the expression within the brackets with cos x and therefore break this integral into two integrals. Let's call the first one I1, the second one I2, and then evaluate each of them separately. Let's start with I1. We should think of this integral as the product of two functions, f dash x and cos x. Whenever we need to integrate the product of two functions, we will typically use either the method of substitution or the method of integration by parts. The method of substitution works when one of the two functions looks like it's a derivative of the other. In this case, we have no idea what f of x is, and therefore we should attempt to integrate by parts. Let us quickly revisit this method. The formula for integration by parts says that the integral of u dv is uv minus integral v du. The important thing to note here is that we will differentiate the function u to get du, and we will integrate dv to get v. Keeping this in mind, let's go back to our problem. Recall the fundamental theorem of calculus. This theorem basically gives us the rule for taking the derivative of an integral or the integral of a derivative. Loosely speaking, we can say that the integral of f dash x dx is fx. So since we know how to integrate f dash x, we will consider f dash x dx to be dv. Integrating both sides, we have v is equal to fx. Notice that we ignore the constants of integration here because we are dealing with definite integrals. So now we set u equal to the other function, which is cos x. Taking the differential of both sides, du is negative sin x dx. So we are now ready to apply the parts formula and rewrite I1 as uv minus integral v du. So that gives us f of x cos x plus the integral of fx times sin x dx. We know that cos pi is equal to minus 1 and cos 0 is 1. So the first term evaluates to minus f of pi minus f of 0. We can't evaluate the integral in the second term without knowing what f of x is, so we just keep it the way it is. We see that the problem also tells us that f of pi is minus 6. Substituting this value, we get the final expression for I1. Let us now write down the final value of I1. Alright, let's move on to I2. Once again, we have a product of two expressions and we will again integrate by parts. This time, however, the problem tells us that capital F of x is equal to integral 0 to x ft dt. Once more, we make use of the fundamental theorem of calculus, but this time we'd like to take the derivative of the integral. Therefore, we set u is equal to capital F of x, so that du is just fx dx. We then set dv equal to cos x dx, and integrating both sides, we have v is equal to sin x. Once more, writing I2 as uv minus integral v du, we see that I2 is equal to capital F of x sin x minus integral fx sin x dx. We know that both sin pi and sin 0 are equal to 0, therefore the first term becomes 0, and we are left with I2 equal to minus 0 to pi fx sin x dx. Let's go back and write the final value of I2 along with I1. Adding I1 and I2, we see that the two integral terms cancel out and we are just left with 6 minus f0. Since I1 plus I2 is equal to 2, we therefore have 6 minus f0 is equal to 2, and therefore f0 is equal to 4. Perfect, so we can finally go back to the problem and put in our final answer. The value of f of 0 is 4.